All right, so what we're going to talk about now is what we call break even, or in economics, we call it zero economic profit. This is a situation where a firm earns zero profit at all. Okay, and we're going to talk about what that means mathematically in just a few minutes. Let me give you a definition for break even. Break even is a financial situation in which a firm is experiencing $0 in profit. Now, that may not sound good to you. I agree. That doesn't sound good to me either. If I own a business, I do not want to be earning $0 in profit. That would be very bad for me. However, I will say that I did own a business several years ago, and even though $0 in profit is not fun, I would have accepted $0 in profit given that for about a year and a half, we spent so much time with negative profit. We were experiencing loss for a year and a half. So when zero profit came around, I was very excited. I was very excited to see that we were no longer losing money anymore. Okay, so there's two ways to look at break even. One way to look at it is that your profit is equal to zero, but another way to look at break even is that your loss is also equal to zero, and it's nice to not be borrowing money and writing checks into your company until it gets big enough to profit and prosper. Okay, so what I want to do here is I want to look at why we have a loss before we break even. Okay, so here's our profit equation. It's total revenue minus total cost. Remember that total revenue is price times quantity. Total cost is variable cost plus fixed cost, right? So here's what I want to propose. What if the quantity is zero? Let's say at the very first day you open your business, you haven't made any sales yet, and you're not about to make any sales. You're going to get out there and try and sell, and you're hoping people will come in and buy your stuff. But right now, quantity is zero. When quantity is zero, that means that we have to put a zero in here for quantity. Also, because we have zero quantity, our variable costs are going to be zero, because our variable costs are associated, they go up as quantity goes up, they go down as quantity goes down. So if I put a zero in here for quantity and a zero in here for variable costs, I can now do some math. Price times zero is zero. And then zero plus fixed costs is just fixed costs. Now remember, in the previous video, I mentioned the problem of fixed costs. In order to start the business, we have to start off with some fixed costs. Now, the business that I started, we had about $250,000 in fixed costs. We had a lot of money that we had to pay out. We had to build out a storefront location. We had to buy a lot of equipment. So we were starting off $250,000 in the hole. And so we were hoping to get our sales up so that we could start recovering those fixed costs. Okay, so zero plus fixed costs is just fixed cost. Zero minus fixed costs means negative fixed costs. And so as we start our business, our profit is equal to negative fixed costs, which technically makes it not profit. It makes it a loss. And so we are starting the business in a situation where we are losing. Okay, and so what we're hoping is that we can increase our quantity so that we can increase our revenues. And if we can increase our quantity to increase our total revenues, hopefully we can eventually recover enough money so that we can recover all of our fixed costs and then begin profiting. And that is the whole idea here behind break even, is we want to know at what point we will no longer be losing and at what point we can begin profiting. So let's look at a couple of the dynamics associated with that. All right, so there's two ways of thinking about break even in a business, okay? You could say, let's say that you have a business and you want to know, well, how many units do I have to sell in order to break even? We're going to call that break even quantity, okay? And the notation is going to be a Q for quantity with a little subscript BE for break even. So break even quantity is the number of units that a firm must produce and sell, Okay, so the number of units that must be produced and sold to earn $0 in profit. Now I want you to remember that $0 in profit also means $0 in loss. And so there are lots of people out there in the world who start a business, and when they get to $0 in profit, when they hit break even, they might have a big party or maybe a little party at home because they don't want to spend all their money and wind up back into a loss. But they get very excited, and they probably go out and celebrate when they get to $0 in profit. Okay, but you can also think about your break-even point in terms of total revenue. The break-even total revenue, which we're going to call TR for total revenue with a little subscript BE for break-even, that's the amount of money, the amount a firm must earn in total revenue in order for profit to equal 0. And so I've got a formula down here for you, which is break-even total revenue is going to be equal to, we know that total revenue is price times quantity. Well, this is going to be price times break-even quantity. So if you just take your break-even quantity, multiply it by the price that the firm charges, that will give you the break-even total revenue. So now what I want to do is I want to take our profit equation and I want to use it to try and understand break-even analysis from a mathematical point of view. So what we said is that a company is breaking even when their profit is equal to 0. So what I'm going to do is I'm going to replace profit with a 0. So we're going to say that 0 is equal to total revenue minus total cost. Well, algebraically now, I can go ahead and add total cost to both sides, and what I now get is total costs is equal to total revenue. And so the first way that I want you to understand break-even analysis is to understand that a firm will break even when its total revenue is equal to its total costs. Okay, so that's the first thing. The next way I want to try and understand it is I want to replace total revenue and total cost with what they are equal to. Okay, well actually I'm going to start with just replacing total revenue, but I want to spin this around, and I kind of want to put total revenue on the left. Just to me, it makes more sense in my mind when total revenue is on the left and total cost is on the right. So I'm going to break up total revenue into price times quantity. So do price times quantity is equal to total cost. And so now another way, by the way, this is the first way that we're going to understand break even. We know that break even is happening when total cost is equal to total revenue. But down here, what I want to do is price times quantity is equal to total cost is, what I'm going to do is I'm going to algebraically divide both sides by quantity. Okay, so if I divide both sides by quantity and cancel out quantity over here, all I have left is price on this side. So I have price is equal to total cost divided by quantity. Well, we just learned what is total cost divided by quantity. Isn't that one of our 12 main variables? It sure is. Total cost divided by quantity, isn't that the same thing as average total cost? Yes, it is. And so here's what I'm telling you, is that a firm will break even whenever its price is equal to its average total cost. And so if their average total cost is, let's say, 20, and their price is also $20, then their price is exactly covering per unit. Remember, price is the per unit revenue. The per unit revenue is now covering the per unit cost, and the firm is earning $0 in economic profit. Now this price is equal to average total cost. That's the second way that we're going to understand break even. We're not going to see that again until unit 3, but I want you to tuck this in the back of your mind, that if a firm, if their price is exactly equal to their average total cost, then they will earn both 0 loss and 0 profit. All right, the last way that I want to look at break-even analysis from a mathematical point of view is I now want to break down total revenue and total cost both. So we're going to turn total revenue into price times quantity, and we're going to say that that's equal to variable costs plus fixed costs. Okay? Now, what we're about to see in here is what we saw in the previous video where we talked about the problem of fixed costs. This mathematical perspective is going to focus on the idea of covering variable costs and then recovering fixed costs. Okay, so here's what I want to do first. I'm going to leave this as price times quantity. And what I'm going to do over here is I'm going to do something interesting and mathematical. Is I am going to multiply. I'm going to manipulate variable cost. You're not going to like this very much, but I'm going to go price times quantity is equal to, and I'm going to multiply quantity over quantity times variable cost, and then I'm going to leave this as plus fixed costs. Now, I want to remind you mathematically, first of all, that quantity divided by quantity is equal to 1, and that 1 times anything is still that thing. So if we did 1 times variable costs, it would just equal variable costs, right? But now what I want to do is I want to manipulate this right here. I'm going to come down here and I'm going to manipulate this to try and convince you that quantity divided by quantity times variable costs. What I'm going to do here is I'm going to put the variable cost in the numerator here, because kind of like what this variable cost really is it's actually variable cost over 1, right? And so now we have two fractions and we're multiplying them, and what that gives us is quantity times variable costs over quantity times 1, which is over quantity. And now what I want to do is I kind of want to separate it now. I want to make it quantity over 1 times variable cost over quantity. See what I did there? I basically just reversed this quantity and this 1. Because it's multiplication, that's a legal mathematical maneuver. But the reason this is important is for a couple reasons. Now I want to look at this. What is quantity divided by 1? Well, that's just quantity, right? So now we have equals quantity times, and what is variable cost divided by quantity? That's one of our 12 variables, okay, in financial microeconomics. Do you recall that variable cost divided by quantity is average variable cost, right? Average variable cost. That is the per unit variable cost. Now, I want to take an aside real quick here, and I want to remind you the example that we did in the video with the problem of fixed costs. Remember how we had the price was $10. We were selling shirts for $10, but that the variable cost was $4. Now, when I said that, that wasn't actually variable cost for the whole business. That was actually the variable cost per unit sold. So what I had written there instead of variable cost was really average variable cost. And so what we were doing was we were taking the price, 10, and subtracting away the average variable cost, 4. So price minus average variable cost gave us $6, and that's what we divided into the fixed costs. We divided the difference between price and average variable costs into the fixed costs. Our price was covering our average variable costs. Then whatever was left over, the $6, could be divided into the fixed costs so that we could recover the fixed costs. And that's an important concept. That's where we are down here. Here's what I'm trying to show you. I'm trying to show you that variable costs can be written as quantity times average variable cost. And that's true because we know that that average variable cost is variable cost times quantity, and if we were to multiply that by quantity, it would cancel the Q and we would have variable cost left over. Okay? The reason I'm doing all this is because I want to go back up here to this formula and I want to replace variable costs with quantity times average variable costs. And all this is going to make sense if you maybe you might have to go back over that little mathematical proof there to understand why this is legal, what I'm about to do. So I'm going to erase that. I'm going to rewrite this as price times quantity is equal to, instead of variable cost, I'm going to put in, let's say, average variable cost times quantity. And I'm going to put that, and then we're going to go plus fixed cost. Okay? All right, so this is now our formula. Now I'm going to manipulate it. I'm going to go a couple more lines here. So do your best to keep up with me. If you need to slow this down or watch it a couple times. I want to solve. Here's where I'm trying to go. Where I'm trying to go with this formula is I'm trying to solve for quantity. Because if I can solve for quantity, where total revenue is equal to total cost, that will give me the break-even quantity. It'll give me the quantity that will result in total revenue equal total cost and a profit of 0, right? And that is our break-even quantity. So if I solve for Q here, and it's going to make it easier to solve for Q by turning this into average variable cost times quantity. Okay? So what I'm going to do now is I'm going to subtract AVC times Q from both sides. AVC times Q. This is algebraic. Over on the right side, it's going to cancel. And all I'm going to have left over on the right side now is fixed costs. But over here, I'm going to have price times quantity minus average variable cost times quantity. Now this thing right here, notice there is a quantity times quantity in this term and times quantity in this term. And one of the things that I can do mathematically here is I can factor out the variable Q. So what I'll do is I'll divide by quantity here and divide by quantity here, put the quantity on the outside, and in parentheses I'll put the P, which is left over, minus the AVC is equal to fixed costs. And now I only have to do one more thing to solve for quantity, and that is divide by P minus AVC. So if I divide here and divide by over here by P minus AVC, on the left side it's going to cancel the P minus AVC, and all that's left is quantity. And so now if I carry down that Q, I get Q quantity, which is break-even quantity, is equal to fixed cost divided by price minus average variable costs. Average variable cost. And this is our third formula. You definitely want this one written down. This, given the fixed cost, if you know the fixed costs, which you usually do, if you own your business, you know how much you paid out in how much you're paying out in fixed costs, and you know what price you're charging, and you do, and you know how much it costs per unit in variable costs, which you should, then you can very easily calculate your break-even quantity. Okay? And I'm going to show you again. This is formula number 3. I'm going to show you again in the example we did in the previous video. Fixed costs were 5,000. So 5,000 divided by our price was 10. Our average variable cost was 4, and that gave us 5,000 divided by 10 minus 4 is 6. And if you recall, we did 5,000 divided by 6, which gave us like 833, okay? And so therefore, in the problem we did when we talked about the problem of fixed costs, that was actually a break-even analysis problem that we did, and we identified that that firm making the shirts would have to sell 833.33, which we would probably say 834. 834 shirts in order to earn 0 profit, break even, and then quantities after that, they would begin profiting again. Okay? So now what we're going to do is we're going to do some examples of solving for break-even quantity and solving for break-even total revenue.